Hi everyone. Good morning, good afternoon, good evening, depending on where you're from across the world. And it's time, so let's start. People who still want to join, they can keep joining, as and when they join, it's fine. But those who have joined, at least all of us can start the discussion, the webinar, and I mean, we call it a webinar, but we always want it to be more like a discussion, very interactive and engaging. We want others to share knowledge, information, network with all other attendees, and that's the objective of this webinar or discussion, whatever you want to call it. Hi, my name is Varun, and I lead marketing at navan.ai. We are a platform. So navan.ai is a platform where we help developers to build and deploy computer vision AI models without writing a single line of code. So it helps organizations and developers to save about 85% of the time that's required in time and cost that's required in developing computer vision models. And that's the first part of what we do. Once the models have been developed and people are already using it, then the biggest challenge is MLOps or machine learning operations, making sure that your models are always serviceable, always up and running. So that's one of the biggest challenges that we've seen in the market, in the industry these days. And that's a service that we offer along with the platform that we have. That is a self-serve platform. We invite all developers to sign up and start using. The sign up is free. You can even build a couple of models for free, so you can start playing around. And then once you are at a scale where at a scale and stage where uh, you've you've already deployed your models, they're running on and in your business applications, and then you need MLOps. Then MLOps is something that we offer as an additional service. So that's a brief introduction about myself and navan.ai. And we'll start today. So we have everyone from our AI team at navan.ai who's joining the webinar. They lead this discussion, and we'll gather insights, we'll share insights, also learn from all of you what issues you face, what are the challenges, what are the solutions that you've tried, what's possible, and then share more ideas from what we have learned so far. So here to everyone, and please be engaging. I mean, do share your input, do share your ideas with everyone. We want this to make we want to make this a learning platform. I mean, this webinar that we're doing has to be informative for everyone. So please feel free to share your experience and your tips, your solutions as well. So I'll sideline from here kind of, and I'll invite Ayush from our AI team. He leads our AI and ML team, so he'll be taking this presentation forward, the discussion forward. Ayush has also been a trainer himself, so long time back, a couple of years back, when we were teaching people how to get started with AI and Python and everything. Ayush was himself a trainer with us, and he's very engaging. I mean, as a student, you would love to keep listening to him, and it's like a store full of information that he has. So, welcome, Ayush, and uh, okay, so Ayush and Karthik both are here, and I think Karthik is going to start first, and then Karthik is our computer vision engineer. He's worked on quite a few projects and has gathered a lot of experience. So I think he's going to start first and share his experience, share his learnings, and then Ayush and the others from our AI team will chip in and carry the discussion forward. So yeah, Karthik, over to you. And thanks again, everyone, for joining.
Yeah, hi Varun. Hi everyone. Thank you. Um, you're able to hear me?
Yes.
Yeah. Let me share my screen. Hi, my name is Karthik. I work as a data analyst here at Sarak, and that involves mainly building the models for various use cases and projects that come our way. And today I'm going to introduce you or talk briefly about one of the projects we did a few months back and how MLOps changed the way the workloads went and changed the overall workflow of the project. Yeah. So the project we did was a product validation and reward management project. Basically, if you think, if you consider a brand X and people bought products of the brand X and they took pictures of it and posted them online. So our AI service would validate those images and give them a reward based on the validation. So it actually involved an ensemble of models, which is like more than a few, close to five different models, which validated different aspects of the products in the images. And only then they would be given the reward. And we had to create a API service for people to access, like get these rewards to access the validation. And the API was supposed to handle over 200 concurrent requests as well, as nearly millions of people would be using this. And one other thing about the project was that the timelines were very packed and rigid, and we had to do a lot of work in very little time. And we had a very small team working on the project and hardly any developers on the client's side, on the client's team. So this is a simple diagram to explain how the project and the API was supposed to work. So people would buy products of brand X, they would take images of it, they would send the images to our API through an app, and these images would be validated by our AI. And so they'll go through different stages of validation, and if the validation is successful, they will be forwarded to a reward page where they will access the rewards. Yeah. So now I'll talk about the various things that changed once we started inculcating MLOps into our project. So the first major thing that was changed was basically with the data versioning. So as you know, for building all these models, for building five different models, we needed data sets. Each of the models required different amount and different uh, featured data sets. And before MLOps, we were storing all these data sets in one single place, and there was no real segregation being done, and no proper pipeline either for the collection of the data. So later on, when once we started with the MLOps implementations, we constructed one single pipeline through which all the data could be collected, and it would be stored in the database based on the various cases, various features of the data set, and based on the various versions of the models. And this allowed us to easily verify the data, quickly access various uh, whatever aspects of the data were required, and also quickly analyze the model's performance based on what data was used to train. The next major thing is regarding model development. So once the data was ready and prepared, so to build each model, it would be a process of running the various scripts and processes manually and overlooking it. And once these models are trained, we would have to manually test them on a prepared data set again. But the overall process, even though it was very straightforward, it would take us 2 to 3 days per model. And for 5 models, it would take around 15 days up to. But later on, we built an ML pipeline which would run all these processes and scripts and train the model as soon as the data is ready. And also after training, it would test the model and export the various model files, which is basically ready the model files to be deployed. So the same amount of work before and after we're able to do in less than a day per model. So basically 5 models would be ready in less than 5 days. Yeah, model deployment. So once the models were ready, we had to deploy these models. So since 5 different models, and for deploying each of these models, we'd have to manually access the client servers and manually load the files and restart the APIs, which is again very straightforward but takes time to do. So later on, we built an auto deployment pipeline, which would just deploy these models directly onto the client server. It would restart the API. And uh, so this kind of auto deployment pipeline also allowed very easy swapping of models in case of any issues arising. So overall, the workflow was automated and very quick to do. Yeah. Other major change was the model log management. So previously, before using MLOps, there were no proper logs for the models. So basically, once the models were trained, we would get the various metrics for it, and the final accuracy values and the various other metrics would be stored. But other than that, we would have no information of how the model is performing, or and if there were any issues with the model, analysis would be very complex and we'd have to test the model multiple times again. But once the training and testing pipelines were built, uh, the testing pipeline would automatically take the data sets and test the model and also log all the results. And since the training logs are also saved by the training pipeline, it allowed us access to all the information during the training, and we could do in-depth analysis of the models, various aspects of the models, and which cases it is good for, which it is not for. And also we could do quick testing whenever required. Next change is about the server performance. So as I said, this was supposed to be an API service, and there were supposed to be 5 models running on the server. And through the API, any request that comes in, all 5 models have to validate these images. Initially, we were running one single API, uh, and all 5 models were running on one single server under one single API, one single process. So because of this, when multiple requests were coming in, uh, as each model had to be run one after the other, the resources were not completely getting used, and also there were a lot of bottlenecks. And overall, the response time was extremely slow. Later on, we started using model serving frameworks, which allowed us to split each model as a separate process, separate API. And the one single main API would communicate with all these models. So even if multiple requests were coming in, uh, none of the models would be staying idle, and each of them would be working on another request while one is being done. Yeah. So server scaling. So the usage of this service was the number of concurrent users were not you know not very standard, as in at some points of time there would be more number of users, and at some points of time there will be very few users. Because of that, if the number of services running or the number of servers running to handle requests would be too few, then when there's higher number of users, the request would be dropped. Whereas if we kept too many servers running and there are too few users, then that would lead to lot of wastage of resources. So later on, we set up an auto scaling infrastructure, which would basically clone and destroy these servers on demand. Basically, uh, when the number of users were increasing, the servers would get cloned. Servers, models, APIs, they would all get cloned and be able to handle multiple requests. And when it when the demand decreased, they would again be scaled down. Yeah. Then another change was the server maintenance. Basically, uh, due to lack of developers as well, whenever there were any unexpected issues with the live servers mainly, so one of us or few of us would have to manually intervene and manually try to fix the issue or restart the server. So this would lead to a lot of downtime, and yeah, this would lead to a lot of downtime, and uh, that's a big issue. So once we later on we built a server deployment pipeline, which whenever there is an issue, any even a non-developer would can could just run it, and the server would be duplicated with all the APIs and models running, and the all the traffic would be rerouted to that API. So this way, anyone, even though there are no developers available, uh, the server could be restarted and there wouldn't be much downtime. Yeah. So overall project development that was going on, from around 3 to 5 developers working on it, data scientists and ML engineers working on it full time. It came down to around one data scientist and one MLOps engineer working on alternative days, and we were able to get the same amount of work done, which was being done by 3 to 5 people. So these are basically the main changes we noticed, or main things that changed with our project workflow before and after adding uh, MLOps methodologies. And even though we hadn't created a complete MLOps pipeline, we had implemented many techniques and methods from it, that our workload was significantly smaller and efficient to handle. So yeah, these are the main things, main advantages that we noticed with MLOps. And with that, we have come to end of part one. So if there's any questions or anything you want to discuss, you can ask.
Yeah. So in part two, so are you going to show how you resolve this all these issues?
Yeah. So part two would be taken up by Ayush.
Okay, great. Yeah.
Before that, are there any other questions or? Anything you want to discuss?
Uh, Not as of now. Yeah, let's go to part
Sure.
two and then maybe yeah.
Okay. Hi guys. Greetings to all. So just now we saw that Karthik has already explained that what all the things we were facing issues at and how we solved that. Pardon me, actually, it's not how, but what we solved in that. Now we are going to see how we solved that and how any AI developer or let's say any developer or any startup or any AI company can use simple techniques which is involved in MLOps and how they can solve these issues. So let's start with first of all, what is MLOps? So MLOps is very new concept. If you see in the market, you can see DevOps is a little older concept, and many of us are aware about DevOps. So can you guys give any idea if you have any knowledge about DevOps? Feel free, guys.
It's a CI/CD pipeline, right? Continuous integration and continuous deployment.
Okay. Yeah.
Yeah. Generally speaking, productionizing all the developments.
Mhm. Okay. So all are aware about at least what is DevOps and where DevOps is used. Many companies and many software developers are using DevOps techniques because, as you said, we need CI and CD, continuous integration, continuous deployment, and we use it because it makes the whole process of software development easy. Uh, so here in MLOps, what we add is extra ML. So DevOps becomes part of MLOps again because we need to handle the software. Because anyhow, when we use the ML techniques, at the end we are going to make a software. That software will be powered by AI or ML. So you can say that the brain is ML, but the software will be the same as a generic software. So there we need DevOps, but there is something called ML, which is additional over here. So what happens in ML and what the external things or external processes or pipelines we need to add to DevOps that we are going to see. So by this diagram, you can understand that there is ML, there is dev, and there is ops. So ML is machine learning, dev is development, and ops is operations. So what is involved in ML is you can see there's a model involved, obviously model training. How model will be trained, we need data. So data is involved. So there is something we need to talk about data and model. Then we have development. In development phase, we need to build a software or build API services or any kind of services which can, or rather, we can plan a software which will use this ML model and solve some problems. And also, it will be adding some databases or some connections. And then at the end, we focus on the operations like we configure, we release, we monitor overall. So, this is how the whole process looks like. Let's go to the next. And here is some more process that we are going to talk in deep. So here you can see there are major areas. So one, DevOps, that you already know what DevOps is. So in ML ops, I said ML is added. So with ML, there are two major things gets added. One is called data and another is model. And that's why I have broken this part into two. One is data ops and one is model ops. Why I'm calling it data ops and model ops, that you will understand because the processes involved inside this area, those areas, I mean, those processes we need to look into. So one will start with the data ops. So what is data ops here? That we do overall data management. When it comes to the ML model development, we need a huge data. You can say big data, whether it's images, whether it's text data, or whether it's numbers, whatever. So we deal with the huge data. So how to store the data, or rather where to store the data, or many times we do labeling because if you see the computer vision and all these processes, we need labeling. We need to store multiple images or the huge sets of data into different formats or maybe into different folders. So at that time, we need to take care about data storage as well as the versions of the data. Why I say versions of the data? Because when it comes to the model training, we need to take care about which data set I used and in what version. So because of that, we need to handle storage as well as versioning. So there we need to collect the data. If you see, you need to prepare it, you need to pre-process it, you need to level it, whatever processing part you do, or you do pre-processing, you need to take under the data ops. And here there's a whole what do you call continuous process, that data management, data storage includes data storage, data versioning, and then you going to release the data. Once you release the data, you can use it for the model training. Now, model training part comes under model ops. So model ops is again, it includes data ops as well as the model and ML modeling, model development. So in model development also what happens is, many times it happens that there are certain experiments you need to do. When you start with some data set, now you know the problem statement, you know the data, you have done some visualizing about your data, and now you have shortlisted few of the ML algorithms, which you think may work on given data and will give you certain outputs. Then you are going to experiment with those ML algorithms. And while experimenting, somewhere you need to note it down so that you can understand that which data, which ML algorithm was suiting and which were not. So in that case, you need to log it. You need to log your experiments. Again, another thing is when you're using your data, you need to use the data in different format, or rather, you need to split it between development, model development, or validation, or training, or testing. So in that case also, you need to take major decisions over here. So in that case, you need some kind of a tools or some kind of techniques to store all this information. So we have not even started the model training, but before that you need to figure out these cases. So that you can get all this information after your model training, and it will be easier for you to take a further decision on that. So hence, we need some experiment tracking. We need log management. While model development, we need to track all these things. Then once the model is ready or model is trained, you need to store the model along with its version and its metadata. So whichever model, let's say the accuracy was this so and so, you need to track this and you need to store the model so that later you can easily open that and you can get all the metadata. So that is what we consider as model ops. So here again I'll go through data ops and model ops. So for data ops, we need data storage, we need a data split, we need a data versioning. For model ops, we need a model tracking, experiment tracking, log management. Then we need a model registries. We call it model registry where we store the models with its metadata. And after that, once your model is ready, you're going to put your model ready with your versions into the registry. Now, from that registry, what you're going to use is you're going to use the model files, whichever model is you're going to use in your system. So after that, model as it is, you cannot use. You need to build some software or some API service or whatever. On top of that, you need to make a cover app of that. So you need to again plan a simple software which will load your model, which will get some input, which will process and give you output. So for that, you need a proper plan of a software, and for that, you understand that DevOps is there already. So we do the system development. We do again all the processes like build, test, analyze, and code, which are very usual processes we use in DevOps. So that is again into the process. Again, there you need to do some versioning. There you need to take care about your databases. There you need to take about multiple connections, and hence there we use DevOps techniques. And again, you need to connect all these DevOps techniques with your model registry or with your model ops, so that this is a continuous process. So somewhere we need to make sure that it's automated as well as continuous. So after this, you're going to release, and then the next process is operations, where you need to monitor. You need to deploy, you need to operate, and you need to monitor. And during this also, you need to collect all those failure cases, which will be collected as a feedback, and again, which will be served to the first process, which is called as model ops. So that failed cases will be again taken as a new case, and the model will again get trained on those cases, and again it will go and put the model into registry. Again, it will track the experiment, put the model registry, again get the model from the registry, put it into system development, deploy it, and again this process goes on. So this is how ML ops overall works. So till now you must be aware about DevOps. Now this is the extra square you need to understand. So I hope till now you have got a simple idea about what is MLOps. So any question till now?
So, regards to DevOps, we use Git, Jenkins, Ansible, Terraform, all these kind of tools, correct?
Yes.
Those are written in various languages. So, what kind of language is used in the MLOps? Just curious, because I don't have any idea about this one.
Sure, sure. We'll take tools and related lecture ahead. So I'll go to that part only after this. So till now,
Okay.
till this, everything is clear. So we'll go to the tools now. Shall I go to the next slide?
Yes, yes.
Okay. So before tools, again, just this is a slide where we'll just focus on some simple parts. So as I said that MLOps is involved data ops, model ops, and DevOps. Now let's understand the major three pipelines which are also there in the DevOps. So if you compare DevOps and MLOps, it is very much similar. I mean, if the person knows DevOps, there are 100% chances that he or she can get a good control on MLOps also. The only thing is you need to understand the tools, and which are very easy, open source, so you can try by your own also. Uh, so we just understand the basic pipelines which are there in DevOps as well as MLOps, that is build, deploy, and monitor. So in build pipeline, because this is MLOps, it also includes the model development pipeline, which are very simple steps. When we discussed last time, I guess I remember machine learning development. Then also we discussed these few steps, which are also involved in the build, saying that we collect the data. So the data ingestion is the collection of data, processing it, and now the data is ready. Then after that, we need to do the model training. So model training itself, I mean, this one block itself includes lot of process. So how can you understand this? That if you see the data, it's not just a data. The data needs to be splitted into different parts first of all. So we need to use some of the data for the training. We need to keep some of the data for the test. We also use sometimes validation, monitoring, because if you use 100% of data into the training, you may not get any chance to test your model or test your software. So to not to do such mistakes, what we do is, like, at the first place itself, we need to split this, and while splitting, we need to put the proportion so that we split the data wisely. So this one also includes that labeling part. If you are using object detection or you are using some segmentation, you need to do labeling. Your labels should be correct and should be stored with the data, with the images. Also, if you are using some text data, then there also you need to do some techniques for the pre-processing. You need to also handle sometimes missing values. So this process is involved in this data ingestion. Next is model training. Now, model training, again, you understood that what are the process involved in model training. You need to go through the different algorithms. You need to finalize one. After that, you need to do, after model training, you need to do the testing. Now, here you will use this test data. Now, model packaging. Model packaging is the model itself is not ready to use. You need to process on that. You need to write some processing code and do the model packaging so that it will be useful for the different frameworks, whichever framework you're going to use for the inference server. There are different inference server. We have TensorFlow servings, we have PyTorch serving, we have NVIDIA servings, we have different kind of inference serving. So for that, you need to package the model accordingly. Then you need to put the model to the registry. So these are the process involved in the build, and we call it machine learning pipeline. Now, next is you need to deploy. So your application should be ready. Application testing should be done. Then you need to do into the production release. So here there's a deploy, and the last is monitor. You need to monitor, you need to analyze, you need to govern, and again this process goes to the build once the feedback is collected. So during this, what you need to do is like data you need to handle. You need to handle the code versioning. You need to handle model versioning. Artifacts is nothing but the model versions. So these artifacts are train model, package model, whichever you going to store in the model registry. And then you have the middleware. Like just now, one question we got that we use Git, we use Kubernetes, we use Docker. What we use for we use Ansible, we use Jenkins. What we use for the MLOps, the extra part where the model ops and data ops comes in. So that we are going to see now. So these are the middlewares. There are on top of that, when there is deployment and monitor, we need to also focus on the infrastructure. So there we need to take a decision on which kind of a computing engine we are going to use, or which kind of a instance we are going to use, or what kind of a cluster we are going to set up. So all these are major areas where you need to take a very rigid decision, and sometimes there are mistakes happens, and the whole overall software gets issues in all the pipelines, so the build or deploy or monitor, or there are some issues where we can't get connected between these pipelines, or there are some issues happens in the automation. So before the automation, what my suggestion is to all is, when we do automate something, we need to first segregate, or we need to arrange this in the correct manner. We need to track first things in the correct manner, and then we need to automate, so that in later stage we won't face any issues. So let's go to the next slide, where you can see now many application names and many frameworks. There are many tools names you can see over here, and uh, so I'll go one by one. Now let's start with the data. Again, here we have three: data, training, and deployment. Now I'm not following here the three what we followed over here: build, deploy, and monitor. Rather than that, we are following data, training, and deployment. Now, when we talk about data, what all the tools which we need to use? So there are few tools which we already know. Like, let's go with one by one. So there are versioning. First of all, versioning. I said that data needs to be versioned properly. Because when we train some model, and let's say I train a model for 15 times for 15 different data sets, and later on if someone asks me that version 3 on which data you were training, so that time I won't be in the position that, so I will be in the position, if I use versioning, I'll be in the position saying that, okay, this data set I used for the version 3 or version 5. So for that, what we need to use is versioning tools. So there is a DVC. DVC is something that we used in our projects. So DVC is data version control. And what DVC does is, it generally takes the data and it versions. Versions in the sense it gives a tag to the data. Also, it stores the path of your data and saying that this is a version, and it stores here and here. So data storage, you can use S3, Amazon, wherever storage you want to use, you can use a bucket. So wherever you store your data, you need to get a path of the data, and then, I mean, data storage, and then you need to version it with a DVC, so that that version file, or rather path file, will be there with your Git repo. So because whole data, like there is a huge data, you cannot put into Git. Git has some certain limitations, if you are aware about. Git cannot add like 100 GBs or 150 GBs or 200 GBs or even T data. So in that case, what you can do is like, you need to store this data into the storage accounts, and then wherever you have stored, you need to take a path. You need to connect it with the DVC, so it will give you data version, and now the path file can be there in your, which is very simple, which is very like not even 5 KB. That file can be there in your Git repo. So from Git repo, you are connecting directly to the data storage. Now for that, there is this tool called DVC. You can later find it out online. It's open source and you can use it easily. They have very good documentation, and you can use that. Now, after that, we need to do labeling. So labeling is there, as I said, there are object detection, model development, where we need to do the labeling. So you can use some labeling tools. There are n number of labeling tools available. Soon, navan.ai will also provide the labeling tool. Uh, in labeling tool, why labeling tool is also important? Because when you get the data after the labeling, you need to also take a format of the data, the correct format, which you are going to use for your uh, further development. I mean, further model development. Because if you are using YOLO, then you need to get a data format into the YOLO. If you are using some other format, then you need to mention it over there. So labeling is also important, and there are some chances that you may automate it later. So that is also important place where you need to select the tool wisely. Now there is a processing. There is a Spark, and for text related data also you can do the processing. So if you are using NLP, or if you are using text classification, you can use the processing. Also, if you have some digit data, like numerical data, you do the processing. You do the pandas. There are panda. You use the pandas. So there are different tools which you use to handle the data. So this is only basically focus to the data. Again, we have the warehousing. Data warehousing is another again way to store your data. So you can use different buckets also. You can use data lake. You can use warehouse. And then there are some cases where you may use the data set into the tabular format. So you can use Postgres. You can use databases. You can use Mongo. So these are the tools you can use for the data. Now, next is for the training and evaluation. While you do the training, you need to again select the frameworks you are going to train. So that can be TensorFlow, that can be Keras, that can be PyTorch. You can see overall whatever frameworks you are using is given over here. So you need to select from them. And while selecting this, why I'm giving more focus on selecting wisely, because whenever you select one tool, you need to also see the connection between one tool to another, because you are going to connect the whole process at the end. So there should be compatibility. There should be less of this tedious job, that this is not getting compatible with that, and that is not again getting compatible with other. So you need to take a wise decision over here. So you need to search such frameworks which is compatible for all of your pipeline, or rather you need to get pipelines such as which is compatible with all this framework. Then you need to do hyper parameter tuning. Then you need to do experiment management, which is very important. And as I said, that you train the model for multiple times on multiple data versions. But while training, if you're not tracking that, what is your accuracy, what is your validation accuracy, what is your loss, what are the different parameters, how many data you use, what was the split, what was the number of parameters, how many epochs you ran, all this data, if you are not logging, that means you are not aware about what each model training gave you. So for that, there's ML flow, there's a tensor board, which will log all these parameters as well as metrics in such a way that later, whenever you get some doubt, or whenever you want to check more about your model training, you can just go there and you can just see, even you can visualize the whole data, like epoch wise what was your accuracy, epoch wise what was the loss. All these data you can get at one step, or at one location itself. So in ML flow, which we use, we can also use the ML registry, I mean model registry, which will again store your model with the versioning, with the metadata. So there is this ML flow. This is also again open source. You can use it or you can check it. They also have very good documentation for experiment management. Then the list we already know, as we say, that resource management. Resource management, we have Docker, we have containers, then we have Kubeflow. Then for software engineering, we have Git, we have Streamline. These are related to the software. We make a software, we build some APIs, or we build some dashboard with Streamline, or we build the whole code with Jupyter. So all this also we store it or we version it with a Git. So this is involved in software. Resource management we already saw. Then we have compute. So here we have GCP, we have Azure. So we use EC2, or we use VMs, we use instance, we use clusters. All this for the compute. And then the last one is for the deployment. So for deployment, again, we use different what do you say monitoring, or sorry, for the deployment we use the web deployment, we use different VMs or cluster, again Kubernetes, or if it is on the edge we use NVIDIA TensorRT, which we recently used. Then we have TensorFlow Lite, we have ONNX. This was also we use in our regular projects. And then we go to the CI and testing, so continuous integration and testing. For that, for continuous integration, we have also used Jenkins. Jenkins is again very popular when it comes to the automating this whole process and automating the pipelines. And then testing, we use different tools. We have K6, we have JMeter. So this is all again involved in deployment. So what is important over here is, as I said, getting the correct tool and checking the compatibility in all over the process. So you don't need to get to know all these tools, because this becomes very overwhelming. If you see and if you go and learn each and every tool, that is not going to add any value to it. What I suggest is, like, you just select one which is very popular and most of the people are using. So you can easily understand that DBC is very popular nowadays. Again, I said PyTorch, TensorFlow is again very popular frameworks. Kubernetes, Dockers, Jenkins, these are again very popular. So these are the already there tools which you can use for your own use case. So you need to first define what is your process. You need to first do the manual process. You need to understand the each and every process one after the another. You need to track at every process, and then you can automate it, so that you will understand that whichever the places you need to automate, you can use whichever tool. Maybe you can use Jenkins, or maybe you can use Ansible. Automation script you can write, or you can just write a simple Python or JavaScript, whichever you are comfortable with, to automate few things. You can do that also. If you are saying that I'm not very much comfortable with MLflow, then you can just track your all logs into the log management. And while model training also, you can collect the all logs and put it in some database, or put it in some let's say place where you can later understand whichever your model was trained, what was its parameters and metrics. So the whole idea over here is tracking each and every step, so that you can later on, you won't get into the confusion that, okay, what was happening when this so and so process was going on. So this is how we use these tools or these techniques to make our work easy. So as Karthik said, that instead of 3 to 5 people in a team, we just manage with one data scientist and one ML engineer. So although sometimes people think that, okay, MLOps needs more resource, or MLOps needs more people on board, that is not actually true. If you understand the MLOps, you get the same response, or the better what is it, better team management, or better project management with limited resources. So for that, MLOps is very much useful. So yeah, this is what we have for today. Uh, any questions till now?
Yeah, thanks, Ayush. Thanks for showing different tools and how the flow goes on. Thanks for that. I have a couple of questions. Are you using this feature store?
No, we are not even feature store now.
Okay, okay. Can you just tell me how I'm like, if you have an idea of how you can connect with the feature store with DVC?
Okay. As I have not used, so can I get back to you on this?
Yeah, Yeah, sure, no problem, not an issue. Yeah.
So
Mm,
for can you just tell what is the use case you are looking for?
no. So as you know, we have feature stores to store different features, right? So different extracted features.
Okay.
So and then when we go into training, so we want to version the data.
Okay.
So obviously we want to version the features which we have extracted.
Okay. Okay.
Yeah.
So in that case, I guess the feature store which you are using, you just need to find out how to get a you can get a path of the feature store, right?
Yeah,
I mean, you
but
can get
yeah,
the path,
feature
right?
store. Yeah, there are different
Yeah.
available feature stores like Feast and it was mentioned Tecton. So yeah, these vendors provide the format completely differently. Yeah, so those that's where I was looking into those angles. Yeah, it's okay.
Okay. So in DVC, what generally we do is in DVC we have to connect to your if you are
Yeah,
using Bucket or if you are
yeah,
using
either
whatever
there is three
feature
or
store, let's say.
yeah,
Yeah.
got.
So you are using S3.
Yeah, I'm like I've used S3. So yeah,
Okay.
I've used DVC actually, DVC with
Okay.
S3, GCP and everything. But yeah, I just wanted to know this connection between feature store and
Yeah.
yeah, yeah,
So similar thing which you
yeah,
need to do over here also. So DVC is only going to use only going to create this path file. Other
yeah,
than that, there is no work on of DVC over here.
yes,
Just
yeah,
this path file you need to keep into your Git repo, because the only thing is wherever you keep this path file, the only reason to keep this path file because you cannot put the whole data into the repo, and
yeah,
later on you cannot connect where the data went or where the features went.
yes, yeah,
So DVC definitely, I guess, whichever feature store you're using, you just need to connect it to DVC. Maybe the connection you need to check
mhm,
what which way you need to connect.
yeah,
So I guess that also I'll also check on this.
yeah, and yeah, as you say this, I'm like, so as I've gone through navan.ai, it looks like an automated machine learning platform for computer vision. So how do you deal with balancing the data sets? So if
Yeah. So
yeah, I mean like the classes.
balancing in the sense you
So uh
okay you while before training we need to balance the data set. That's
yeah,
what
yeah,
you're asking.
yeah.
Okay. Karthik, can you take this question?
Yeah, sure.
Yeah.
Um, like balancing. So in general, you must be knowing of various methods, right? Like
Yeah, then
either you sample.
sampling. Yeah. So, is that
Yeah,
the similar approach you also follow?
yeah. So we use sampling as well as defining weights based on the balance,
Okay.
like during the
Class
training,
weight.
and yeah,
Uh,
yes.
okay.
And other than that, we also make use of augmentations.
Yeah. That's where I was interested in. So as you said, into computer vision. So how are you handling this with images and videos, basically?
Yeah, so like augmentations, basically, there are many options, but since this is a no-code platform and the augmentations have to be more generalized,
Mhm.
so there are only a few options which you can choose, which can work safely for most use cases. So such augmentations we have chosen and we have applied.
Okay. Hmm. Okay. Yeah.
Any other question?
Yeah. About one other one. What do you use for monitoring the logs? So basically, are you using Kubernetes?
Yes. Kubernetes. So for this project, we have not used Kubernetes. For client projects, we have used the one Karthik showed, the case study. For
Okay.
that, we use Kubernetes.
Yeah. So how do you use to monitor the logs and metrics?
Okay, so metrics monitoring is in which metrics you are the Kubernetes metrics, correct?
Anything. So if you are using some instance to train, so the training server, let it be your training server or let it be a Kubernetes cluster. So how are you? I mean, like, how do you manage to get the
Okay, so
logs
there
and
are a few things like when it comes to the, because we use most of the GPUs. So for us, only CPU metrics won't be sufficient. We
okay.
also need a GPU metrics too. So as well as log management, we use logs from pod logs that we already collect. So there is a log management. We internally manage those. We don't use any external or open source tool for that.
Mhm.
Second one, for the metrics, actually, the inference servers we use, this is from NVIDIA Triton, which we use, which gives the metric logs also on the same VM or whatever, or the node. So we get the logs inside there itself and metrics too.
Okay. Okay. So how do you I mean, like, trigger the retraining approach? So so if say you have a certain metric and based upon that you want to retrain the model again, then how do you handle that?
Yeah, so right now, at this moment, we have not got any such requirement for the retraining, like automated retraining or feedback
Okay.
system or anything. But the retraining, what we do is like it based on like if there is, as Karthik gave his case study. So in that retraining, they wanted on different product SKUs. So that was all manual because
Okay.
that was not for the collected data. There was also collected data which were failure cases, but that
Mhm.
was again not very usual. So we didn't have any automated feedback collection and retraining, but we
Okay.
do that for manual.
So it's like
And
you run the complete pipeline and get the one version of the model, and then if
correct,
you're not satisfied, then you again trigger the pipeline.
again trigger the pipeline. Yes,
Oh,
correct.
yeah, I got it. Yeah, yeah. Thanks for that. Thanks for everything. Yeah,
Thanks,
that's
thanks
all I
for
had.
wonderful questions.
Yeah.
Anyone else?
Hi Ayush, this is Yogan.
Hi.
Hi, I have a small doubt. So, in the training block, you have given some software platforms, right? Is there a
Mhm.
platform where training can be performed on GPU and it can scale automatically based on the workload that's given? Because
Yeah.
Fargate
So
is there, but it doesn't have GPU.
okay. So do you want a platform where you are training your model on the GPU? So right now in Navan AI, what we are training, we are using GPU.
Okay.
So because this is completely based on computer vision, and we can only use GPU to accelerate. I mean, we cannot use this on CPU because CPU it will take uh, like it will be very tedious to train
Yeah.
on CPU. So we only use GPUs, and also when we deploy on GPU. So we use
And one,
accelerator.
yeah, one doubt about scaling. So, you're saying, for example, Colab is there, right? So, you'll be
Mhm.
having a predefined set of configuration which will be working for
So
training.
we are okay.
Yeah.
So right now we are not training this on Collab, right?
No,
So
no,
we are
I'm just assuming because even in EC2 there are GPU instances, but they have a fixed GPU size, right?
correct, correct.
Is is there a way where we can scale based on our need?
Yeah, so training wise, you if you ask me for training, uh, there
Yeah,
is difficulty in that. But when you go to the deployment, again, as I said,
yeah,
that while
deployment I
deploy,
get it. Yeah,
yeah, deployment you already have. As I said, we use Triton, so there
okay,
you use the optimization at the best level. Training wise, if you want to use single GPU for multiple training and all, there are few ways to do that. We have tried that also. So maybe we can connect later for this discussion.
okay, thank you.
So this is the correct the question was this only, right? Like if you have one GPU and you want to use the multiple training on that.
Not one GPU typically. So imagine like a cluster, maybe.
Mhm.
Yeah. So is there any platform that offers such kind like Dynamically
Okay.
for training, I can increase the number of clusters.
Okay. For the training purpose.
Yeah.
Okay. I'll check on this also.
Hey, hi. So those all of you who had questions and have something more to discuss, I've shared the email ID on the chat, and you can just drop your question so that we know how we can reach out to you. We don't have everyone's email ID, so just do that so that we can respond to your questions. Then.
Okay, great. Yeah, thanks for that.
Any more questions? All right then. Sushmit, do you want to go ahead?
Uh, I guess I will be sharing the feedback form.
All right. So, guys, it's a request for everyone, a request to everyone. So, Sushmit will be sharing the link to the feedback form in the chat box. Please do fill in that form and help us with feedback so that we can make the content better, more relevant in the upcoming webinars. There you
Then
go.
should I also share them the calendar invite?
Yeah, you can do that. Yes. So Sushmit will share another link in case you want to talk about MLOps, you want to talk about navan.ai, you want more information. You can schedule a one-on-one call with us, and we'll be able to answer more questions on that call.
Okay, great.
Yeah, I shared him. The first one is a feedback form, and the second one is a calendar meet link. If someone is really interested, or they have any Q&A or something. I just saw someone has asked Karthik to ping me, so you can directly use this platform as well.
Yeah.
That's it from mine. Thank you, guys.
All right. Thanks everyone for
Oh,
joining, and we're looking forward to your feedback. So please do fill in the feedback form. And if you have any questions, anything you want to discuss, obviously, you can schedule a call with us. So thanks for joining, and all of you have a great evening.
Yeah,
and
thank you.
happy Pongal from Sarak side.
Yeah, sure. Yeah.